And the handout is dealing with dilution, right? And so let me recap. Let me add a page. Add a page in here. And I'm going to recap what we already talked about with um, so I'll recap what we talked about so far. We've talked about molecular formula, and this is just a recap. 3, 14, 22. I talked about molecular formula, and with that, we talked about empirical formula and formula units. We talked about percent composition. We talked about molar mass, molecular weight, and how to manipulate between molar mass and moles and molecular weight. We've also, so all these things are dealing with the concept of moles, and then we started talking about concentration, which is moles of solute over liters of solution. And we did a bunch of different manipulations with this as well, right? We figured out how to go from moles to grams of solute, and then we've also figured out how to go from grams to moles, and then figure out the concentration based on that if we're given a volume. So we did a lot of different manipulations with concentration as well. So the next step in the progression is dilution. And that's where you take a solution and dilute it to decrease the concentration. And the equation for that is, I'm going to say M1 V1. You probably remember this from high school when you see it this way, equals M2 V2, right? So with any dilution equation, you can solve for any other variables if you have 3 of them, right? As long as you have three of the 4 variables, you can solve for the 4th one. All right. So any of your 3 variables, you can solve for the 4th, right? And so when you're doing dilution, again, you are basically changing the concentration of one of your solutions. If you're a biology major, you're gonna need to like do dilution often, right? You'll have a lab, or maybe you've already done it, where you do what's called a serial dilution, where you start out with one concentration of a solution, a medium, and then you keep diluting it until you get to a specific concentration that you're looking for. So this is the same thing. All right. So with that being said, let me do this. I'm gonna cut. I don't know if we're gonna have enough room, but I want to cut these out. Yeah, cut them out. I'm just gonna write down here. See below. So when you when you're looking at these in the notes, after I post the notes, you'll know that the solution, we worked all these out on a different page. Page here. All right. So we're going to start out with the first one, because you see what the question is asking. What is the molarity of the diluted solution when each of the following solutions is diluted to the given final volume? So it's giving us everything that we need. It's asking us what the molarity or the concentration is when whatever we have is diluted to a given final volume, right? So let's look at A, and I'm gonna solve A in here. All right, so it's giving us, it says 1 liter. So we have a volume, change that. 1 liter of a 0.25 molar solution. So right away, we can see that this is going to be V1 and this is going to be M1. In the book, it might say C1, V1, where C is just symbolic of the concentration. But it's the same thing and you manipulate it the same way. There's no difference, right? And it's giving us, it says the solution, come on now, is iron nitrate, iron 3 nitrate. And it's diluted to a final volume of 2 liters. We don't have to do any other calculations. We don't have to convert iron nitrate into moles. We don't have to convert it into grams. We don't have to do any of that. All we need to do is set this up like this. M1 V1 equals M2 V. Sorry about that. I bought a new stylus. I'm still trying to get used to it. M2 V2. I got to buy one of those anti-palm gloves so I can actually write like I would write on a sheet of paper. Then I'll be set. Till then, just bear with me. All right, so M1 is 0.250 molar. V1 is 1 liter. So let's put those numbers in. So 0.250 molar, we'll keep that. V1 is 1 liter. And then we're going to set this equal to M2, which we don't know, right? We don't know what the molarity of, we're trying to find the molarity of the second of the diluted solution. So this is M2 times V2, which is, what did it give us? 2 liters? Yeah, 2 liters. So 2.00 liters. Everybody following that? And let me make sure that we don't have no confusion here. One liter, 1.00 liter. How do we find M2? If you can do this question, you can do any dilution question. How do we find M2?
Just get it by itself.
Get it by itself. And what would you do to do that?
After you multiply M1 and V1, then you would divide V2.
Divide everything by V2. That's exactly right. So this is going to be 2.00 liters. That's going to cancel. And then this is going to be, and I'm on the rest of these, hopefully, we got more room. So we'll be able to work them. This is going to be divided by 2.00 liters, right? What do we get from that? So M2 is what? Should be 0.125, is that right? 0.250 divided by 2.
Yes, sir.
If you can follow this, you can, any dilution equation is going to be the exact same. The only thing that's going to change is the numbers. The only way to throw you off is to change the units, right? Sometimes you might see the volume in milliliters. All your volumes have to be in liters. All your concentrations have to be in moles per liter. So if the concentration is given, you're not gonna have to touch that. If the volume is given in a different unit with a different unit, maybe it's milliliters or microliters even sometimes. If that's the case, convert it into liters and then set up the equation. That's the only additional manipulation you might have to do is to change the units of your volume. All right, so let's do the next one. And again, it gives us V1, 0.5 liters of a 0.1222 molar solution of, what is that? C3 propanol is diluted to a final volume of 1.250 liters. So again, all you're doing is setting up the dilution equation, but not with a highlighter. M1 V1 equals M2 V2. What are we looking for here? Let's go back to the initial question. What is the molarity? See that up there? So all of these questions are asking you to find M2. What is the molarity of a diluted solution, of the diluted solution? So everything here we're solving for M2. So all we're doing now, let's just go ahead and do this here. And then put the numbers in. So this whole side divided by V2, it's going to cancel. This divided by V2, is that right? Equals M2. So M2 equals M1 V1 over V2. That's the setup. Now we just need to put in the numbers. So 0.5 liters times 0.1, yeah. Divided by V2, which is 1.25 liters. And you might ask, like, or be wondering, like, why this is important. So let me give you an example of why it will be important. So let's say you have your TA and you're working for me, helping me to teach CHEM lab. And we have some cobalt nitrate, cobalt 2 nitrate, and it's 10 molar. Somebody made it 5 years ago. It's just been sitting on the shelf. and we need 1.2 molar solution. We could take that 10 molar cobalt nitrate and just dilute it. We can find out how much if we know M2 and we know how much of V2 we want, we can figure out how much of the cobalt nitrate, the 10 molar solution we need to take out and then dilute it up to a specific volume, right? So this is a very important concept. And it may seem like kind of mundane because, oh, we just manipulate numbers, but this is something that's used every single day in every single chemistry lab in the world. There's some dilution going on. So it's a very important concept to understand. Can somebody give me these numbers right here? 0.5 times 0.1222 divided by 1.25. Anybody got that solved yet while I was running my mouth? Anybody? 1.25. Anybody got that? 0.049 molar.
Yeah, I got that.
All right, good. All right. So let me see where we're going with this. All right. We know the setup. This is the setup. We're looking for M2. So M2 equals M1 times V1 over V2. Let me get somebody to volunteer to solve this one. You have V1, you have M1, and you have V2. This is just a matter of plugging numbers in. It's not the hardest part of the chapter, but it's something that you're going to see a lot. This is like actually a skill to know how to do dilution. So it's not something that I could just gloss over. All right. Do I have a volunteer to work through it, talk us through it?
I got you.
All right. Come on with it. Help us out.
Okay. So M1 is going to be 0.350.
Good.
Times 2. 35 over 4.00.
All right, so we're gonna put those numbers in.
And
0, you said times 2.35, good. And this is in liters divided by 4.00 liters. Is that right?
yes,
All right. What do you have after you calculate that?
I'll put it in real quick.
Okay, take your time.
I got this long number, but I don't know if I put it in right.
Screw that up. I saw I put 0.035. It's actually 0.35. What'd you get? Let me see. Let me try to match it. 0.350 times 2.35 divided by 4. I think you put in 0.0350, what I wrote on the screen. If you did,
Yeah.
that's my fault. I got 0.206 molar. Anybody else got that? That's my fault because I put 0.0350. That's okay. It's the Monday after spring break. We good. We're gonna survive. Yeah, I see you, Maya. Yep. All right, good. So this is again, this is the reason I put so many of these is because the more you do, and thank you for your help. So you got 0.0205. Yeah, that's because the point of if the 0.0350. If you make it 0.35, then it's gonna be 0.206. But I see the number and I agree with it. It's just off by a decimal place because of me. So I'll take the heat for that. All right. Let's do the next one. What do we have to do here? What do you notice right away? See, that's what I like to call a trap, because you working through, ooh, we're feeling good. Oh, knock this right on out, and then boom, you get it run into a question like this, and you're not thinking about the volumes having to be in liters. What are you gonna do? You're gonna put those numbers in just like they are. You're gonna get some crazy number. It's gonna look good, and then I'll get an email. How did I miss this one on the test? Oh, you forgot to convert to milliliters. Always convert your volumes into liters. All right. Can't stress that enough. All right. So 22.50 milliliters. If we convert that into liters, basically divided by, well, let me not say that. We're going to do it. So 22.50 milliliters times 1 liter. This is the conversion over 1,000 milliliters. So that's going to cancel, and you're going to get 0.02250 liters. All right. Same thing with the V2. You got 100 milliliters, so you're going to convert that. This is V1. This is V2. 100 milliliters times 1 liter over 1,000 milliliters. Milliliters cancel, and you'll get 0.1 liters. Following? Everybody following that? You have to convert your volumes into liters because the molarity is in moles per liter. And you're given that. So now it's just a matter of setting it up. M1 V1 over V2 equals M2. We're going to take M1, which is 0.025 molar. That there is a zero in front of that one. And then we're gonna take V1, which is 0.02250 liters. We're going to divide that by 0.1 liters. All right. What you're going to notice with these dilutions, this is common sense. If you dilute something, you make it less concentrated, not more concentrated. So your second concentration ought to be less than the first because you're diluting something that up to a higher volume, right? So the higher the volume, the lower the concentration is going to be when you're doing a dilution. All right, so that M2 ought to be a number that's smaller than M1. So let's see what we get from that. Anybody got it calculated? All right, anybody got this? 0.0056 M. Anybody got that?
I got the same thing.
Good. All right. So the key here is just keeping the, I know it sounds like crazy, but just keeping the decimals where they're supposed to be so that we are using the right numbers. Other than that, this is not rocket science. This is probably the easiest thing in the chapter. It's just a matter of knowing how to manipulate the equation and then knowing what that, all the chemistry, the hardest part of chemistry is trying to understand what the questions are asking, interpreting the questions. That's a skill. That's why we do things the way we do them in order to help you develop that skill of being able to interpret what's being asked for. Once you do that, then you can take the given information and manipulate it to get what you need. Right? But you got to know what they're asking first. All right. Well, what about, let's see, let me turn y'all loose. I'm gonna give y'all 5 minutes to do, well, no, you don't need 5 minutes. Well, y'all give you 5 minutes. 5 minutes to do 11. And then we're gonna move to I'm gonna move number 12 down while y'all doing that. I'll give you 3 minutes to do number 11. And the time, well, let me pause the recording too, because that's 3 minutes of dead time on YouTube. That's not good.